So after my power failure, trying to compute this confidence interval, I'm looked up 95% confidence. We're using degrees of freedom 14. And the alpha is 0.05, but alpha over 2 then becomes 0.025. So I'm here with 14. I've got tail probability 0.025. Looking for 14. 2.145 is the critical value. All right, so that's what goes here. I was going to point out, though, if we use degrees of freedom more like what the calculator had, it was something like 25. That corresponding critical value is like 2.06. So you get a slightly wider interval using this conservative estimate for degrees of freedom, a slightly narrower one if you take the degrees of freedom from the formula, which we'll show you in a minute. So my task is to see if I can't type all that stuff in there without screwing up. So far I haven't been that successful. We'll try one more time. You didn't get to see it because I just laughed and started over. Okay. So 104.93 minus, but I'm not making a point, 0.93 minus, okay. And the other mean was 129.07, okay. I'm going to put those in parentheses just to be safe, although it wouldn't matter. We would be fine either way. And then plus, there's a plus or minus there. I'm just going to try plus. And put the t in there. 2. Oh, it's the 145. 2.145, and then I'll go square root. Okay, then I want S1. I said 13.9. 13.9. I'll square that. Come over and divide it by n, which is 15. So the first sample was size 15, and then plus. Second standard deviation was 19.4. I see a point, no, 0.42. Square that. Come over 1. And divide that by its sample size, which is 15. Now with luck, we'll match what we had. The confidence interval we got before, this is what we're trying to get, was minus 36 to minus 11. Now we know we're not going to be exactly that because this used different degrees of freedom, came off the calculator. Okay. And this is just using an estimate. There we go. So that's the one side with the plus. That's the least negative side. How do we do? So minus 10.913, it looks like this. So we got minus 11.44. So it's a little going to be a little bit wider. And then if we go second enter here, it'll retype all that. And then we'll just scroll on back to where that plus sign is. Make it a minus sign. Oh, so there's the minus of it. And that's supposed to be the minus 36 approximately. Minus 37.367, like that. So that's the by hand calculation of the confidence interval using degrees of freedom 14. If you use the formula, what did it say in here? We go stat test, 2 sample t-test. And we run this through. It said degrees of freedom is 25.36. It has a way of interpolating to get the t value that goes with it. So to get the tail probability that goes with that we would need for the confidence interval, it'll use that degrees of freedom and interpolate. We used 14. It uses 25 something. So if we put 25 in there, we'd get this value. We get pretty close to what the calculator gives, but still not exactly the same value. Okay, and then we're going to do the by hand version of t, which is x1 bar minus x2 bar over square root s1 squared. I'm looking at this and going, I've got this already entered in my calculator. Maybe it's still there. There it is. Maybe I could make it happen by going second enter. Now I'm just praying. Okay, and we come up here, go back here, Maybe I can delete my way back to victory. What do you think? Maybe I'll probably screw it up though. Delete, over, delete, over, delete, over, delete. One misstep and I have to type it all over again. So there is the bottom. So that's a 6.166. Well, I'll leave it like that, 6.166. And then up on top, I've got the 104.93 minus 129.07. Look at that carefully, crank it up. Minus 24.14. No, we said the calculator gave me minus 3.91. We ought to be pretty close here because these are all the same values the calculator is using. It has nothing to do with degrees of freedom to get t, so we ought to be on target. If we're not, I'll be kind of sad. Minus 24.14 divided by 6.166. So there'll be a tiny bit of rounding happening here. 4.07. So we rounded here. And so that, do we see what it was? It was 16286. Maybe if I put a 28 here, see what happens. It should be very close to the right thing. Try that one. Minus 24.14 divided by 6.16628. Oh, try it again. Minus 24.14 divided by 6.16628. There we go, minus 3.91 due to rounding. Or if we cared, minus 3.914 or something. Okay, so those are the two calculations carried out by hand. Nice, and let's see, we would then, we want to see what we're going to do with this number using the tables. So using the tables, we'd use degrees of freedom, probably 14. We'll come back over to the tables here. We're looking for something like minus 4 across here. And here are the two values on either side of our computed value. So the tail probability is between 001 and 0005. I'll write that down. The tail, I was going to write it down, is between 001 and 1, 2, 3, 5. So I'll make sure that's right. So we're in degrees of freedom 14. We're down here, 4.1 and 3.7. So it's the 3.91 is between those two. So the tail probability is between these two. Okay, but it's a two-sided test. So the p-value is between doubling those two values, 0.002 and 0.001. Of course, we're using degrees of freedom 14. And what that does is give you a larger p-value than you would use if you had degrees of freedom that we use for the calculator. And we said the p-value from the calculator was the calculator 1, 2, 3, 6, like that. So pretty close to 001 is the answer to that. And that makes sense because our computed statistic value is closer to 4.1 than it is to 3.7. So we're closer to that for tail probability. So we're closer to this for doubling it. And so that's closer to the actual answer. It's between these two and two. It's between this one and this one. Closer to that one. that if you use the actual degrees of freedom, get a slightly smaller p-value. That's already tiny. We would reject the null hypothesis in each case. So that concludes our description of the two-sample t-test in all its glory, with the calculator version and the by hand version, and what happens if you use the reduced degrees of freedom. We have one more slide to talk about, and that talks about some of the details that we were talking about, and we'll just finish that off in one more recording.